Hey everybody, welcome to the weather breakdown. Today is January 3rd, the first weekend of 2026. Now, as we move into 2026, I want you to work on a consistent rhythm of the channel. And I want to take the time now to wish everybody a happy 2026, whatever that may mean to you personally. Now, I started the channel around February 2025, but due to regular job, other commitments, and working on the ChaseBuddy, I wasn't really able to churn out content on a consistent basis. And that's something that this year I'm actively trying to change. So from here on out, you can expect more meteorological updates ranging from short-term forecasting to longer-term forecasting to meteorological deep dives. And the meteorological deep dive can go from the basics of meteorology to advanced meteorological concepts. The aim of the channel is pretty simple. Provide a clearer understanding of what actually drives the weather and combine it with practical forecasting so that you can interpret those forecasts in a much more reliable way. Okay, now in our first video of the year, we are just going to look at how the weather looks like today on January 3rd, and we can see how the weather will change in the next coming days over Europe and what the European people can expect. Okay, let's dive straight in. So if you look at our weather chart right now, we have the following situation. We have a low pressure area here in Scandinavia. We have another low pressure center here, centered just to the southeast or southwest rather of Portugal. This sets up an airflow like this, warmer air moving north here. This low pressure area, aided by a high pressure area here, funnels frigid air over the warmer ocean bodies here, leading to a frontal boundary, as you can see depicted here, connected to this inclusion to this low pressure center. As all this air here moves south over the warmer air bodies, you can see signals of convection here, and this is fueled by colder air rushing over warmer water bodies, leading to an unstable air mass, leading to convection. The air in central Western Europe is cold enough so that precipitation falls originally as rain, but since it's already like 2030, temperature is already cold enough so that it actually falls as snow. You can see also there are some thunderstorms happening here, meaning the convection doesn't need to be that deep in order to tap into the upper region in the atmosphere where charge separation is possible. So discharge of lightning remains in the possibilities also in the coming night and the coming days ahead. So let's look a little bit what the weather charts look like in the coming days and see what we can expect. Now, if you look at our weather charts here, we can see the exact same as we have seen in our observations. You have a low pressure center here over Scandinavia. You have a low pressure center here to the southwest of Portugal. Judging by the 500 millibar height contours and the MSLP field, we can see the flow moving like this. So there's warmer air circling around the low pressure center moving north. Conversely, around here, around this pressure center, you can see the 500 millibar lines and the pressure field, seeing that there's airflow moving like this, leading to this boundary, as you can see here, connected to the occlusion of this low pressure area as we have seen in our observation. What we can also identify here is this low pressure center, as time progresses, will start to move in that direction. You can see a low pressure center here. This one will move in this direction, while this low pressure center gets a little bit more complex, but it stays more or less around this area. So as this low pressure center moves here, you can see here, the more you go to the north, 2012, 2016, 20, 24, 28, there's a high pressure center here. We've also seen this in the observation not too long ago. As this low pressure center will start to move to the north, this one staying here with this predominantly north-south directed regime, this area of high pressure will start to migrate towards the south and the southeast. And this has massive implications in what will happen in the next coming days. Let me show that actually occurring. Let me remove everything here. Let me rock a little bit back and forth. You will see this, as you can see here, you will see this area of high pressure moving towards the south and the southeast, as you can see here. You can see ECMEF, the European model, is actually doing the same, as you can see here, right? More or less the same scenario, where you can see this high pressure area starting to migrate towards the south and southeast. And if we go to the GFS again, if we rock this forward now, you will see that as this area of high pressure sits here, it sets up an avalanche of west to northwesterly flow moving like this, more or less, towards the east and southeast. And along this flow, right, you will see disturbances in a serial manner moving along that axis as well. They call this in meteorology serial cyclogenesis. And you'll see the serial cyclogenesis regime starting to manifest itself. So if you go forward, you can see this area of high pressure, which has migrated from the north towards that location. And you'll see now here, low pressure area 1 starting to form, number 1. You have here number 2. You have here number 3. You have in its wake number 4. You have in its wake number 5. You have in its wake number 6. And it's not only GFS that's saying this. The European model is telling the same story, although the trajectory of those disturbances, that's something we will need to look further into as time progresses, and the more runs are being calculated, fine-tuning the trajectories of these lows if they even occur. So let's do the same thing with the European model now. You see this area of high pressure area starting to manifest itself, moving south and southeast, and it sets up the exact same. You have an area of low pressure now here, moving like this, as you can see. Yep. All right. Let me erase this. You'll have another one in its wake. You can already see it here. Number 2. You have number 3. You have number 4 in its wake. You have number 5 in its wake, and so and so and so on. That's why they call it serial cyclogenesis. It's cyclogenesis in a repeating pattern. Now, what this means in the future, we just don't know yet, but we do know, however, if we look at the temperature field, that this has implications on the temperature as well. If we go forward now in time, you will see here temperatures flirting actually with 0 degrees as time progresses, as this westerly to northwesterly flow starts to manifest itself, that this cold, let me take my pencil, the colder temperatures here will start to migrate towards the east as well, right? So let us do that right now. You can see this right now happening like this. Both the European and the GFS model tell the exact same story. You can see that boundary of cold air moving east, as you can see here, just as the ECMEF is doing, but as low pressure centers start to manifest themselves here or linger there, it diverts all that cold air again like this, leading to a boundary that's more or less situated like that. We will deal with some cold, but the cold will be washed away, albeit perhaps temporarily. We will see what the next runs will bring. Now, in terms of precipitation, we can also identify some interesting stuff. If you look at the precipitation type, you can see here, as we've already discussed, let me take another color here. As we've already discussed here, you have this avalanche of colder temperatures moving over warmer ocean bodies here and water bodies in general, right? This sets up a unstable air mass. Why? Because you have cold air coming over a warmer water body. The contrast between them means that there's warmer below than there is above. It's actually frigid temperatures above, meaning there is convection going on. And that convection falls as snow in the beginning. It falls as snow. Why? Let me erase everything. Why? If you look at the 850 millibar temperatures, you can see that the temperature is actually between -5 and -10. So it falls as snow at first, but if you look at the temperature at 2-meter height, right, you can see actually that it's rather positive here, meaning that it falls as snow first, right? Or today, it fell as snow first, but along the way, it started to melt as the precipitation fell into a warmer air mass before reaching the ground. Now you can see that happening constantly, but as you can see here, this is already like night. Okay, you can see that the temperatures over land are actually quite cold, which means that today, the 3rd of January, precipitation started as rain, migrated towards a mixture of rain and snow, but deeper in the mainland, it will actually fall as snow, leading to some potential of a few centimeter accumulations here. Now, as we've already mentioned, this doesn't last that long anymore, but there is a nice intermezzo that I would like to show you guys. If you go a little bit further, you can see the precipitation signals start to decrease a bit as the forcing for it decreases. Why does the forcing decrease? Well, it's not too hard to understand. If we check the 500 millibar lines, they are moving like this. More of the forcing is actually here. If you look at this regime is actually a negative vorticity advection regime, leading to more of a subsidence. And you can see that also here in the darker brightness temperatures and water vapor. There are some precipitation signals here, but those are not really upper level forcing related. Those are more related to convergence boundaries along the coastal areas and the North Sea in general. If you go a little bit further, you can see this low pressure area here migrating towards the southeast. And as it migrates towards the southeast, you can see on the GFS model that it leads to a frontal boundary where snow might be the predominant factor in France, Holland, and Belgium, and parts of Germany as well. Now, the European model goes with the same solution, more or less, as you can see here, but the precipitation signals are much more intense. So depending on which solution will actually happen, we might get quite some centimeters of accumulation, but we will see in the next coming days what will happen, okay? So we can conclude our video by saying that it's cold right now. We have some wintry showers to deal with some potential snow accumulations if that snow keeps falling as snow and the temperatures near the ground are cold enough not to let the melting process begin. We have also seen that around 7th of January, there might be some interesting stuff going on with a cold frontal boundary where the GFS is pointing towards a more or less weak precipitation signal, but the European model is coming with the same frontal system, but the cold front is more active, producing more precipitation, leading to potential accumulation of a few centimeters before the northwesterly flow comes in and washes the cold to the east again. We'll see each other in the next video, guys. Hope you liked it. Bye, everybody.